sign.
There we are. Future generations will be able to see this as well. Cool. Okay. It feels so much more official. Okay, cool.
It's like that speech in Police Academy.
I've seen Police Academy, but not in a while.
So if you have seen that one, haven't you?
Yeah.
I think our YouTube stream just got flanked.
We haven't hired anybody to sit under there.
Cool.
That's very much police. We should make it a girl-free one.
Can you just check whether the elephants are?
I don't think they are.
Turn it around. You can turn it around and it's being shot.
You can go to the front.
You're going to be asking questions.
Hi, Lisa.
Alright.
Oh my God.
That was part of the entertainment.
No, all right. Is the screen off then?
No, that's gone.
Okay. Cool. Okay. So, Kubernetes, introduction to Kubernetes. Hands up if you've heard of Kubernetes.
When I got the invite through.
Yes, excellent. So this is trying to explain some of the basic concepts of what it is in relation to our plan, how we might use it. There's like obviously a lot of detail that I can't go into because it'd take too long, because it'd be too boring. So it's just like explaining some terms. There's a bit of technical stuff, there's a demo. So it's explain Kubernetes, talk about why it would be worthwhile. There's a money bit, and there's a demo Q&A bit. So, and there's props. We'll get onto those. Hopefully this is more useful explainer tool than sort of slapstick. It's yeah. Cool. So, oh, incidentally, this is Slide Bean. I used it for the last time as well, and we have an account now. So if anyone wants to do slides as beautiful as these, with as many animated GIFs, actually I've only got one in this one. It's not bad. Okay, so Kubernetes. That is Kubernetes. That is how the ancient Greeks say it. It's a Greek word, and it means like helmsman, which doesn't make much sense until you realise that it builds on something called Docker. And Docker, it's kind of like, well, a ship docks, therefore Kubernetes helmsman, that kind of makes sense. And you don't really know why ships are involved until you realise Docker works with containers, which are like shipping containers. So some clever Linux guy, actually Docker sort of, I think, coins the term, decided that containers were a thing. How do you manage containers? Docker. And then how do you manage Docker with a helmsman? Let's do it in ancient Greek. There. So to explain Kubernetes, you need to the name Kubernetes, you need to explain the name Docker and containers, and the same is true of Kubernetes itself because it builds on those things. Right, first then, containers. What's a container? This is a container. As you can see, it's got some stuff in it and it's got like a nail in it. So containers, part of a physical machine. So imagine this is a box, like a machine box. It is a box. Imagine really hard it's a box. So like this is a PC or a server or whatever. If you've got a virtual machine, it's like a smaller box inside it. Yeah, there's a physical aspect. You need full attention. A virtual machine is like another complete computer, like almost emulated within it. There's some efficiencies and so on, but this has Windows running on it, and within it you'd have another PC effectively running Windows or Linux, whatever. Containers are slightly different. They go in boxes. You can fit many containers. I invested in 3 in one physical box. The way they're different is that they're not a virtual machine. Within this container, there's some files you can see by the orange Play-Doh, and there's some process. So the rubber that I got from Ryman's is like a executable process. So that is within a container, but it's still just running on this machine. It's not like there's not another operating system. So if you're running a Mac or if you're running Linux, you could have all your programs. Some of the programs would be just cordoned off in like a sandbox. I tried to find some sand to put in the boxes to demonstrate the idea of sandbox. So this is just a lightweight way of separating off files and programs so it can run super quickly and efficiently. Sandbox didn't have any sand. And why would you use this over a virtual machine? Virtual machine, literally, you boot up your PC, and then within it, another PC or machine boots up and has its own operating system, its own memory management, its own files to 10 gig of Windows 10 or whatever it is. So there's a lot of overhead. With this, it's not. It's just a cordoned off bit. Containers, sweet. Docker. So Docker is a nice way to make containers. If a container is a collection of processes and files and all this stuff, and this is a port that's been exposed, then Docker helps you define that. So what is a Docker file? This is a Docker file. So a Docker file, I wanted something a bit more physical, is a set of instructions about how to make a container. So let's follow some instructions. So the point is, you use these instructions to build a container, and then you take an image of it, you take a snapshot of it. So this, if it were an image, I could then instruct Docker to run that image, put it in that machine, put it in that box, and run it. It's like it's all prepared and it's super quick. But before that, you build the image. So let's build an image. So with Docker file, it says here, I'm going to start with another image. So this one here, as you can see, has .NET Core SDK installed on it. So the first line says, I'm going to start with this. We'll see a proper Docker file later. So start with this. It says, make a folder. OK, I've made a folder in the file system. Copy some source in. Got the Play-Doh. Yeah. So I'm doing the job of building a Docker image at the moment. You see, it takes some time. Not particularly skilled. That's actually also quite a good thing. Yeah. So here's some source code actually, and then it says build the source code. Oh, I've got source code all over my thumb. It smells great. Oh, we'll have questions at the end. If you ask a good question, you get a pot of Play-Doh. Like this. Anyway, so I've built the app. I put it in there, and then it says I need to expose a port. Now, this is not the right kind of hammer. But it's the one I found under the stairs on the way out the door. So effectively, a port, this is all sandboxed and contained within the container. If it wants to talk to something outside of it, it needs to expose itself, expose a port. So, yep, it split. The other one didn't split. I thought I'd be all right. This is the slapstick bit. There we are. Right, so I have built a container. Thank you. Then I can take an image of that, and I don't need to do that again. So what the bit I was demonstrating there was, it took some time. I started with a pre-built one, and then I added some stuff and took a snapshot. Now this, I can instruct Docker to go and start it on my computer, and it will make it. It will put it there. It's done. It's invoked. Likewise, this is an image you could then base other stuff on. So if I wanted to say, oh, start with whatever this Docker file produced, and then, ooh, got like a rubber band, that might do, and then extend it, I could have another Docker file which says, yes, build on this. So for example, there's a base Docker image for like WordPress or something, and then we might have a Docker file which says start with WordPress and then secure it or something, and that's another one. Anyway, you can build on it in that way. That is Docker files, and there's way more to it. You can tag them, you can label them. So I'm going to call this, what should I call this? Bool. This is the bool image, so it's tagged bool. Right. Why Docker? Why use Docker? Immutable deployment. So the idea of this would be a version of our app. So we put together some instructions for Docker. We said, take the code from the latest code from my app, put it in the file system, build it. You could even run some tests, make sure it's all right or something, and then take a snapshot. So this is version 1.2.3, and then you can run it locally, make sure it works. Oh, it does. You can then say, put it on the test environment. It'll be exactly the same because it's an image. You can put it on the live environment, and the point is it's immutable. You can't, I should have got some tape. You can't get in there and then tweak it. You can change it. It's an image. You can't deploy it to live, fix it a little bit, and then you've got something that's out of sync. You've got in your live environment, there's some changes that you need to have documented somewhere. If you want to make a change, you have to build a new one, put it in. do it again. It's a, so that makes sense in terms of immutable deployments. Is the advantage clear? It's kind of, if you just have servers and you copy up files and tweak config files, you need to remember what you've changed. If you set up a new environment, you need to remember what to set up. With this, you just do it. And you can take this Docker image and say, run it on Google Cloud, run it on Microsoft Azure, run it on AWS, Amazon AWS. You can run it on your PC, you can run it on a server, your mum can run it, your dog can run it, anyone can run it. It's cross-platform. Right, Kubernetes. So Kubernetes is used for container orchestration. So it's like you've got some containers, you can fire them up, but there's much more you can do. And Kubernetes controls the whole process. It can look after things. I can't remember what happens when I press next one here. Right. So a metaphor, let's use an actual orchestra or band as a metaphor. So imagine Kubernetes as, or say I'm up here and I've got I didn't get a baton, but say I was conducting and you guys are containers, I'm sort of overseeing everything. I'm not going to do that too much. But I'm aware, for example, of the number of seats. So with Kubernetes, there are multiple nodes and servers. Let's have a look at the next one. Dodgy diagram. There are multiple servers, and Kubernetes, when you say, give me bool, it will know which server has some space free, and it will put it on that server, and it will look after it, and that kind of thing. To go back a step, drummers are unreliable, so if we're going for the musician band idea, you could say to Docker, don't use Kubernetes, you say, give me a drummer, but the drummer is asleep, he doesn't start work properly, he just dies randomly, chokes on his own vomit or something, and that's it. All you can do with Docker is say, run this container, run this image. With Kubernetes, you say, I expect, the percussion to be happening, and I know that involves keeping 2 drummers there, so that if one dies, there's still someone else playing the drums. So with Kubernetes, you declare what you expect, and it makes sure it happens. If the drummer dies, scoots them off, puts a new one there for you, that kind of thing. And if there's loads of drummers, it will make sure they're all in sync. Right. Yes, make them dependable, drummers. The drummer thing comes back in a minute, but we're going to talk in more real terms about Kubernetes things. So if this is a container, what is a pod? I'm just going to see. No. Well, it is a pod, so there's only one slide for this. So a pod is a container or many containers, hence the rubber bands, with specific images. Imagine that this one's this one's the ball image, and this is his friend, and they need to be deployed together. Okay, the drummer thing. There's a drummer container and a groupie container who deals him enough drugs to keep going or something. So he always needs his buddy container with him. So a pod defines something that can be deployed and work together. So it can be 2 containers, but they're tight. And they might even have this bottle this is the remaining bottle that the cats didn't knock off the counter and smash. This is an extra disk drive or something, so they can use that as a drug cache or something. Anyway, so this is a container.
I'm not sure this will be going on YouTube.
Yeah. So there's 2 containers, and it's got a label. So this is a fully functioning percussion section pod. And it can have requirements as well. So you can tell Kubernetes that's going to use 2 cores of CPU and 3 gig of RAM. And this is the smallest thing you can deploy with Kubernetes. Now, a pod could just be a container too, but it's important to note it can be many containers. There's more to it as well, but that's the basics. Okay, pods make sense? Wonder why they're called pods? Never really questioned it. Peas in a pod? Peas, pod? Kind of makes sense, doesn't it? I'll go with that. Okay, so the next thing, this is the terminology section, is something called a replica set. So with Kubernetes, you can say, make sure because even with his even with his mate feeding him drugs, he's not super reliable. With Kubernetes, you can say, I want a replica set. Make sure that there's at least 2. I didn't bring enough, but imagine this is another pod. There's always 2. So this is the bit where Kubernetes, if one of them disappears, it doesn't respond, you're poking him and he doesn't even say ow, then that will be gone and it will give you another one. So a replica set is like an eyeball watching over and saying, make sure there are always this many pods running and they're identical. So that's handy for like load balancing and dealing with failures. If one of them's down, the other one will still be responding to requests. So incidentally, the container we're talking about here for our projects is the back end to our apps. It's the API bit, it's talking to a database and it's doing the clever logic. It's the bit that you want to keep up and running. So replica set, no one really uses these directly, but it's important to point it out to point out its shortcomings. So if you wanted a new version of your app, Bull 2.0, which is in purple, it would get rid of all of these and then give you Bull 2.0. And in the meantime, it's been down. It's been down. Yeah, the service is unavailable. There's like nothing there. So it doesn't deal very well with like updating. So everyone uses deployments instead. Behind the scenes, a deployment actually does use replica sets. So that's why I kind of wanted to flash it up there as well. With a deployment, you say the same thing. I want 2 Bull 1.0. And then you can update the deployment, say, okay, now I want 3 Bull version 2. It will make them as well, make sure they're all good, and then get rid of version 1, all the while traffic's still being flowing and everything's hunky-dory. So deployments is what you use. So pretty much we'll define a deployment which includes replicas, containers, images, all that stuff in one go usually. And you say, Kubernetes, make it happen. Does that make sense? Cool. Deployments roll out changes safely. Right. This is almost the last bit of terminology. A service. So at the moment, this has been in Kubernetes, and these little openings here that allow it to talk to these to talk to the outside world have just been sitting there. A service is how it's exposed to the outside world. So we want this to be accessible to the public. So you create the concept of a Kubernetes service, and you say, go and find any pod with a certain label. So every pod in the deployment have the same label, and a service will route all traffic to the nails, to the open ports on all of these. And if you do the new version, they'll have the same label. Take that one off, and you can see that the service is basically a load balancer. Stuff comes into Kubernetes on a service, and then that points it to the pods. Goes and finds pods with a certain label. Services can be internal as well. So usually we're talking about building an API that's going to be on public internet. There might be services, pods, deployments that are used internally by the system. So they'd just be internal services. So this Bull might need to go and check the gravity service to know how high to bounce. So there'd be a gravity service which might have in turn a whole load of pods, containers, and this could talk to that internally. Cool. Right, so something I've said a few times is that these might disappear. The idea with the cloud is that resources are somewhere managed by something and are generally unreliable. You should consider any one of these things as unreliable, that it might pop out of existence. That's why Kubernetes exists. It says, if this falls over and dies, I'll give you another one, don't worry about it, and it monitors everything. So the question is, if that just disappears, what happens to the data that was on it? The answer is the data disappears as well. Even the one in this little drugs cache file drive just disappears, it's gone. So if you want persistent storage that persists, across depth of a pod or a container, use a persistent volume. That's the last concept. Persistent volume, like this, stays there in Kubernetes always. It's usually, so if you're running on Google Cloud, it's a special thing Google Cloud put there, and one pod can connect to a persistent volume at any one time. So it doesn't really work with replicas. There's a way around that, something called a stateful set. But this stays Drummer dies, new drummer comes in, connects to this one, which could store the state of what he was doing, where he was, how much he owed his dealer, and all this sort of stuff. Right, persistent volume. So those are the concepts of Kubernetes, since pods might disappear or reappear. Why use Kubernetes? That cloud is raining money. So it can happen both ways. You can spend a lot of money in the cloud very easily by saying, oh yeah, just give me a server and chuck a load of stuff on it. Or you can be very clever and careful and provision things carefully and use resources wisely and efficiently. So Kubernetes gives you the second one, obviously. So in case we were going to put this out on the internet, I've renamed a certain project as Gemstone, and I did a quick monetary dig in. So we host on Azure on something called an app service plan, on the standard S1 plan, which is pretty much the lowest tier, which gives you something like, is it 1 core or 2 cores of CPU and 3.75 gig of RAM. So most of the time, Gemstone dev environment, which is 3 different components, I think, API server, the web server, and the worker process, typically consume, oh, I've done it the wrong way round. Well, it costs £108 a month, but it only uses 0.2 of the 2 cores and 2.1 gig of the RAM. So even though we've loaded 3 things onto it, and they want to be together on that server, it's not using much of it, but we can't go any lower, and we can't load other customers, other project stuff into it. So we're stuck. But if we were to use Kubernetes, you can make a custom virtual machine in the cloud, so a custom place to custom one of these, and it's shaped and sized perfectly for our needs. So you can say, I want it only to have 1 core as a processor, but 10.5 gig of RAM. And that is basically, because you can't go less than 1 core, so we multiplied everything up by 5. So you could fit, so that costs £37 a month, first of all. And it will hold 5 of those environments, so it ends up costing about £7 a month, which is less than £108 a month. So there's a few caveats. That's basically when it's sitting doing not much and just plodding along. You know, if we have to do some heavy lifting, it would use more processing power, but even if we used 5 times the processing power, it's still 1/3 of the cost of Azure. It's still £37 a month, not £108 a month. Cool. Other reasons. So that's a good one, obviously. But monitoring, scalability, obviously you can keep track of these things. Scalability meaning if you want not to have 2 replicas but 10 replicas, I'll show you. It takes about a second and you've got 10 replicas. So if it's under heavy load, you can throw more stuff at it. Reliability, self-healing. If something goes kaput, it restarts itself. There's health checks. So you can say to Kubernetes how to check that this drummer is alive. Pokey, pokey, pokey. If he doesn't respond within 2 seconds, assume he's dead and just turn him off, turn off the life support. Cool, self-healing, deployment process. So all the deployment things about immutable deployments we spoke about. And it's not just for our stuff. You can get Docker files, Docker images, and containers, and all kinds of things for Kubernetes. For example, our WordPress site is hosted on Kubernetes. Or if you need an FTP server, you can spin it up on Kubernetes. What other third-party things? Pretty much any kind of server or service you can imagine.
TeamCity.
Yep, TeamCity, so our CI build system. And it uses the resources efficiently is the point. We don't need a... Also, is anyone on the 8-box? Doesn't happen, basically. There is no 8-box. You don't need to remote in and do stuff there. You just connect to the service. Why do we do that? Actually, out of interest, John, when you say 8-box, 12-box, what are you doing when you connect? And I'll see if there's a parallel. Yeah.
Normally looking to see whether the service is up and running or something like that, or I get a particular file off it, like a backup file, something like that.
Cool.
Generate from one project.
Okay. So a backup file would be a completely different route to do. There's not a. You can log onto a server and transfer stuff and download stuff. You can log on to an individual container. You can also look at the logs of a container if it has any output. And indeed, you can check if a service is running. That's the easiest thing in the world. In fact, it should not be running. You know, it's automatically started. Cool. And for us, Octopus Deploy is how we deploy stuff. At the moment, it goes to Azure App Services, or it goes to Well, it doesn't with Octopus. It's always Azure, isn't it?
That's from the 7 box, some stuff that's live, like the older projects.
So we've got a few things that push out as well. But Octopus is supporting Kubernetes soon, which will make it easier. And there's something called Helm. So if you've got containers which are defined by Docker, which are managed by Kubernetes, deployments and collections of deployments and other, so if you've got a deployment and a service, deployment, service, persistent volume, and another deployment that all make up an app, how do you do that? So you need something else called Helm, which again, Helmsman, Helm, they're continuing the ludicrous shipment-based naming. Helm is another language. Docker uses Docker files. Kubernetes uses YAML. Won't put in controversial opinion there. Helm also uses YAML, but with templating. And I will put in controversial opinion. It looks rubbish and it's hard to use and it's all indented nonsense. Right. But once we crack it, obviously it becomes super easy. Demo and Q&A. So any questions before I give a demo? Yo.
So how much overhead is there in general compared to just running a VM?
How much overhead does it add? I'm just repeating it for the mic. How much overhead does it add compared to a VM? I don't know. I know that if you're running a VM on your PC, it takes a while to start up, and that there's a definite performance hit. In theory, there is no overhead. If you're doing it on Linux, containers are built into the kernel. It is zero overhead, so it's infinitely better because it's going to zero. Yep, cool. Do you want to see something? Yeah. Ooh, yeah. So, in this demo, we are using Google Cloud Platform because we have a Kubernetes cluster there. And there's a little web interface, which I won't go into too much detail on. But by running a certain command on your prompt called kubectl proxy, it will allow you to browse on your computer and see Kubernetes. So this is Kubernetes. We have all kinds of stuff going on. And what we'll do a quick Saffron demo app, and we'll push it up and see what happens. Just to give you a quick flavor, if I go on the overview of everything on our cluster. So there's a nice thing here, overall CPU use, memory use. We've got a list of other things I didn't mention, cron jobs, something that runs on a schedule. Daemon set is something that runs on every single node that starts up, every machine. Deployments we know about. Jobs runs once off, runs as a once off. Pods we know about, replica sets we know about. Ingresses we don't, but services we do, so on and so forth. And there's other bits and pieces. Cool. So we will deploy the simplest Saffron sample, which I've put together. So let me show this first. So if you haven't seen Saffron 2, this is a complete Saffron 2 app. That's the main entry point. Yep. This is where we define the services the app uses. And here's an endpoint. So default endpoint, you do a get to the root. And you're going to get back a response saying answer and machine name. I'll show you. So we need to be in there, .NET run, bop. So what this does, when you browse to the app, it says the answer is 42 and the machine name is the machine name I'm on right now. Machine name we've got there so that we can demonstrate stuff exploding in the cloud and automatically finding another one. Pretty simple. So we have a Docker file for this. It's actually this. No one can see this, but I'll show it on the screen. Here's the Docker file. Can you see that? Bigger? So we start from the .NET SDK image. We make a folder in there. We copy all the source code in. You can do this the other way. You can build it outside the container and just put the built one in. But this is just a demo. We move into the folder we copied the source into. We restore packages and build the app. We put a nail in it to expose a port to the outside world. And then this is how we're telling it to run it when it actually puts it there. So that's a Docker file. So we can first of all build that into an image. So I've got a really long path, but hopefully you can see that. So we say docker build. That's a -t. It's a dark theme. So what we're going to do, we're going to build it and we're going to tag it because we know we're going to send it to Google Cloud. So we're going to put a label on it which says where it needs to go in the cloud. So we tag it EU Google Container Registry.io Red River Software Project, and it's going to be called Saffron Simple Sample. But we need to point it to the Docker file. So we say use a file in the deployment folder called Docker file. Hit enter. I did it wrong. T build. Did I put a space in it? If and the folder it's got to run in dot, which is current folder. Unable to evaluate symlinks in Docker path. Oh, I'm in the source folder. I'm in the wrong folder. Do that again. Docker build T EU GCR IO Red River Software Saffron Simple Sample. We're going to use Docker file. Yeah, and I do need the dot. Cool. So it's running all those things, doing a little storing packages. So this is just the one-off build process. Buildy build. It does need to upload. So then the next bit we need to do is upload it to the cloud. I'm also streaming, so it might be a bit slow, but we'll see how it goes. So gcloud docker push. So we're going to push that image to Google Cloud, EU, GCR, IO, Red River Software, Saffron, Simple, Sample. Super. There's a warning because they're going to get rid of that syntax and do another one. There's a bit of command line stuff involved. I guess because it gives you the finest level of control. We'll be doing like scripts and using Octopus deploy, so we just put that into place in one area.
Question.
Yo.
So can anyone build or push jar GCR?
You need to be authorized against it. So this is all set up. Yeah, I've just started typing stuff, but we're using something called gcloud, which is a command line tool. That's what I'm using right now to push it, and that you have to set up first and log in, and then it's configured and it knows where to push it. Likewise, the other one we're going to be using called Control, as in Kubernetes control, is already pre-authorized and authenticated already, so anything we do, it knows where to go. It's pushed. So next thing, we've got this, that's in the cloud. We now need to tell Kubernetes to create our deployment or our stuff. So first of all, we create a namespace. So in Kubernetes, you can section things off. So we've got different projects and internal stuff and that kind of thing here. So we create a namespace, Control, create namespace, Saffron samples. It's done. And then we're going to tell it to create a deployment. Very briefly, I'll show you the Kubernetes YAML files. So when we're describing a deployment, which you remember is a pod description plus a number of replicas, here's how it looks. So it's YAML, so it's this weird indented thing. Basically says there's a name for the deployment, there's a label. We're going to have 3 replicas of it, and it's going to be this image that we've just uploaded. The port that's open is 5000. To check whether it's alive, just do a quick GET request as we did in the browser there to port 5000. That's that. There's another part. We're also going to create a service so that we can access it, and a service looks like this. It's a load balancer. It's going to point at anything labeled with simple app, which is our demo, and it's going to take that port 5000 and expose it as port 80 so we can use it with a web browser. Cool. So you can tell it basically to process all YAML files in a folder and deploy that, so that's what we're going to do. So Control create -f for file, And we're going to look at everything in the deployment folder, and we're going to deploy it into a namespace called Saffron Samples. And done, it's deployed. So that's instructed Kubernetes to do it. Now if we look in Kubernetes, we'll refresh it, look at that namespace and see what's going on. Red River, so we have Saffron Samples. Yeah, so it's all done already by the time we refreshed. There's a deployment called Simple Deployment. It has 3 of 3 pods. It's a pod. And they're all running. They've been running for 14 seconds. They're using a few, kilobytes of RAM. Behind the scenes, deployment user replica set. The service is still being set up, so to create a load balancer on Google's servers takes a few seconds. And once it's there for good. So let's look at the service here. Service. So by the time I click through, it's done. So if we click on this, this is our service on Google Cloud. So what you can see is it's responded with the answer we expected, and it's also got the name of the machine on Google Cloud, which in this case obviously relates to one of the pods. So we're going to destroy it and see what happens. So if I refresh, it's clever enough to know one person's session should probably go back to the same pod. Things like if this has loaded all that customer's data, it might still be in memory, so it's clever about that. But we're going to kill that pod, kill it with fire, and see what happens. I'll go back to the overview. So they have a similar name. So this is F49 and ends with GF8. So I need to zoom out. Which one was it? DGSF. Yes, this one. So anyway, we'll kill it, delete, and then quickly I'll refresh. It's gone to another one. So that's the clever bit. And if we look back here, as you can see, that one's being created. The other one still shows there, but it's being shut down. It doesn't refresh live, which might be cool. But if I refresh the screen, there's another one. And if I really quickly try and delete them all, delete that one. Now it refreshes. No, delete that one. So this is the automatic self-healing failover, because it might not be a delete, it could be a crash, it could be that one of the machines goes down. Kubernetes will find a new machine to put it on. If you're out of space, it will provision a new machine, or Google Cloud will. And you can see it's still working. Uninterestingly, it's just working as it should. Hello.
When you're moving up a new machine, is there an amount of machines you can move up at that point? In your content study, you don't have unlimited drummers to keep replacing. Is there an end point of
So there's, for the benefit of the microphone, asking if you can create unlimited machines and stuff.
Yeah, so if you carry on falling over,
yeah.
At what point does it go, right, that's it, you've had enough drummers?
You don't deploy machines, you deploy deployments, which ultimately deploy pods. Everything at its lowest level is a pod. You could ask for a million pods, and it would do its best, and they would stay there in a state whereby you're going to run out of space on the actual node, so the actual box. That one does happily fit. But at some point you run out of space, so it will wait until there is more space or try and create more space. In terms of if it makes it, and the drummer never wakes up, and it tries again and he doesn't wake up, it has something called exponential backoff, so crash loop backoff I think it's called. If it doesn't start up, it won't do it straight away. Well, it'll try again straight away, and then it'll give it 5 seconds, then it'll give it 10 seconds, then it'll give it a minute, then it'll give it 5 minutes, then it might give it 10 minutes. So it's not, if there's a failure, it doesn't try to make it worse by just trying it again and again and lots, so it sort of backs off. But you can ask for as much as you like. Cool. There's one more thing I wanted to show really, which is scaling. So we've got 3 pods here, and if this service was being hammered by hundreds or thousands of people, it would be load balanced between them, no biggie. But say that wasn't enough. That's the wrong button. We can say scale, and we can say, well, I want 10 pods. Click OK, refreshes. I'll refresh again. You got 10 pods. I like that power of just being able to say, make more instances. Say you got a load of backlogs. If Opus was using this and this was the worker process, and you wanted to get it to index the search index quicker, you could just scale up the workers, or they could detect that they're on high CPU and automatically fire up a buddy. Likewise, if we wanted to scale it back to 1, based on cost or something, cost of the nodes, it's going to kill them. So if I refresh, some of them will start going a bit weird, and eventually it'll go back to 1. And all the while that I'm doing that, I still get the service up and running. Cool. Stop talking now. So any questions, anything else I can demo around Kubernetes? Why we want to do it, what the problems are? Remember, questions get played, oh. Now are there any questions? Hey, John.
The deployment side of it.
Yeah.
Deploying various different environments, doing dev, test, and then onto live. With those pod systems, will that deal with conflicts, i.e. you're applying a test config, you're applying a live config, so that you can never ever deploy a dev config onto...
It's a low-level tool. So Docker is super low level, well, containers are a super low level tool. Docker made it a bit more friendly so that you can use Docker files. Kubernetes said, well, that's a bit difficult to manage. What if something goes wrong? So it adds that, but it certainly doesn't tell you what you can do. Now, the other day, I was typing commands, and I typed something like kubectl delete namespace, and then I put a namespace tag, saffron samples, or something like that. I think there's a space there. And it complained because it said, well, there's nothing to delete, or you need to specify what to delete, or use all if you want to delete all. Problem was I made a syntax error, so I was about to do this, which actually deletes all namespaces. And that namespace saffron samples doesn't seem to have much of an effect. What I meant to do was that, which I do. Oh, not found. What did I call it? Oh, saffron samples. There, that's deleted it. So all those resources are now gone. It's nice and quick. It doesn't stop you doing anything. That's why you'd build on top of it with. So some people just do it all from command line, but
Yeah, that's why I'm only really is it the right config goes on and everything?
yeah, no, that would be through Octopus. So Octopus are building in support for Kubernetes. They're going to use Helm as well. So we'll be getting in with that as well. It's just, yeah, it doesn't know what a deployment. It knows what deployment is. It doesn't know what an app is. It doesn't know what safe is. It'll just do exactly what you ask it to. Would you like black Play-Doh? Yes. Hey. Cool.
Do it actually like that?
Green.
No, can we not be like signed up to play that? I think I have responsibility to like be responsible with it.
Don't eat it.
But it makes colours
Too late.
together.
At least that's the most.
Just the load balancing.
The rainbow, the fact that you want to share a data.
How does load balancing work with the fact that they have to share a database? So I guess there's a couple of bits there. First of all, how do you do a database with Kubernetes? If you've got pods which come in and out of existence, obviously the files in the pod, the files in the containers can't have a database on them unless you really don't care if it disappears instantaneously. Usually, you don't host databases in Kubernetes. They are hosted, in the case of most of our apps, on SQL Azure, and you talk to those. Each of the apps services requests and talks to that central database, but that's it. You can host some databases. In fact, you can host all of them on Kubernetes. Some of them do it better than others. You can use something called a stateful set, whereby you say, I want 3 replicas of these pods. Each one has a persistent volume, but there's a persistent volume for each replica, which never changes. So if this dies, it brings up another one with that same volume. If this one dies, imagine there's 3, it brings up another one and attaches it back. So with that way, you can have 3 different instances of a database that's load balanced. I guess, I don't know if that's exactly what you're asking.
It was just because my impression was for if you had a server that was just getting cameras,
Yep.
but it was just bottlenecked by the database call.
Yeah.
Like it was just adding replicas wouldn't fix
No, it might make it worse or something. So if it's if you use something like a database outside of Kubernetes, you'd need to scale that up. If you are using a database that does work with Kubernetes, for example, CockroachDB, which is particularly good at it, called Cockroach because it can just, survive the nuclear fallout, etc. If you blow up all of the pods, they'll still somehow survive or whatever. then you'd scale that up. You'd scale up the database, and that would be sitting behind a service, just as your app is. So the app, each of the pods would use that service internally, which is load balanced. Yeah. So databases are tricky with it. Oh, what colour do you want? Oh, okay. Next person gets 2. Another one for John.
Yeah, it's actually somewhat related to that one, and it's based on if you're deploying a different data set as part of an update,
Yeah.
you're deploying a new version to live, are you able to deploy simultaneously and have version 1 sitting alongside 1.1 and therefore
Yeah.
do a sort of
So
non-downtime deploy?
John is saying, can you do a non-downtime deploy? Can you have version 1 sitting alongside version 2? You can do pretty much anything with it. You can do rolling updates, whereby traffic will gradually be moved over from the old version to the new version. You can just deploy another one, and then just turn off the old one, so you can have a new address. And you can do funny things on the front end to route to the new one. You can do what's called blue-green deployments, which is where you create a new environment, make sure it's all good, then you'd switch over DNS to the new one, get rid of the old one, usually called blue-green, because you'd keep the old one and update that, and then you'd switch between them. There's all kinds of things you can do, but the control, the power, complexity lies with the person using Kubernetes. It has the tools to do rolling updates, do a canary update, so you could say, oh, have 10% of requests serviced by this new version. If there's loads of errors, cancel out. That's the way Facebook do it. If it's all good, then roll it up to the rest of them. Obviously, we're talking about huge scaling issues, which at the moment we don't have. But yeah. I'm really not a confident Play-Doh thrower, but that was pretty good.
Following on from that, if version
We'll do Ash next, because he had his hand up. That's right. No, after you.
Okay, yeah. So
Just
following
start.
on from that, if like version 1.2 had a migration to database,
Yep.
is there currently a way
Oh,
that we
yeah.
can do that?
That's screwed, isn't it? That's an issue, because when you deploy a new version, it wants to use a new version of the schema. So if you have them side by side, one of them is going to fail. First of all, the new version, while the database is in the old state, and then the old one. So you can do clever things like deployment hooks. If you use like Helm does some of these things and gives you more tools to do deployments. This stuff's complicated, right? There are benefits, but like you've got to learn a new language for Docker. You've got to learn a whole new language and set of resources for Kubernetes, and then another templating language, and understand how dependencies work for Helm. But you can do things like spin up these pods in a controlled way, then wait for this, then run this, then do this. It's the same problem you'd face pretty much anywhere else if you're doing this kind of thing. You can route requests, keep them routed to the old one. You can typically you'd if you really want zero downtime, you'd have your database schema sort of backwards and forwards compatible, or you'd use feature flags to say either use this field or don't. But with Entity Framework or things that require a certain schema, it's tricky. Entity Framework Core, happily though, doesn't check what migrations have been applied. So if you're just adding a field, the old version actually would continue to work. It just wouldn't populate that field. So it's just hard. Yeah, you want to play the black one? Cool. Ash.
Is it possible to have fallback on a completely different cloud service? If
Yes.
Google Cloud, for instance, were
Yeah.
running like your main service like
You can do something called federated clusters, which I looked into and then wept a bit. It's really complicated. I mean, even this stuff obviously is fairly complicated, but it's once you're over the learning curve, there's good benefit. So a federated cluster, you can have some nodes on Amazon in the East Coast, some on Amazon in West Coast, some on Google in somewhere else, and so on and so forth, some in Amazon. If you wanted, I believe you could have some running in the office here, and I had that thought a while ago about old PCs and laptops that we're using. It's really fiddly to set up. It's still fairly new. You can do it, but at some point you've got to work out, is it worth the engineering effort to make that work, test it, make sure it doesn't introduce more complexity. It's like if it goes down, it really is a business decision to say, can we deal with the occasional half an hour downtime? Most people can. Anyway, what colour do you want? We've got a teal, a pinky, a blue, a green and a purple. Why does John want it? Pringle.
For the
Yeah. Yeah, I mean, it's all of these are years old by now. Kubernetes is pretty solid. I mean, so this is what Google use for Google. Most people, it's an interesting thing to do. It is something like this, or this, is necessary for microservices, which is, as everyone knows, people foam at the mouth, buzzword, whatever. Interesting thing I saw on, we were talking about it yesterday, weren't we? Tech Radar from ThoughtWorks. They say you should investigate, spike out this technology, you should consider this and adopt this. And they say they're never going to say, pretty much so they're never going to say adopt microservices because it's too complicated. Just thought I'd say that out loud. Yeah, so definitely. And what colour do you want? Blue. Oh, sorry. Too much spin. Jake, we've got 3 questions left, that's it.
Through this dashboard you've got here, how is it to set up the sort of automatic spin up of the new machines kind of thing when it comes with the heavy load?
So interesting. I was confused when I started using Kubernetes. The first thing I did was how can I tell how much is being used? So we had 2 or 3 really cheap Google Cloud machines, and I was like, well, I've deployed some stuff. When am I going to run out? Isn't an easy way of doing it. Can't just say, what's my usage? You can see CPU usage, memory usage, and there are commands where you can establish it through a series of, but yeah. How easy to spin them up? Google Cloud Platform, doing the thing. Pretty easy, obviously, as you can kind of tell because I'm pressing the buttons. You have node pools of nodes. So we go to, it's different for Azure, different for AWS. The point is, once the machines are there, it's all the same Kubernetes. So we go to Kubernetes engine, clusters. So we have our Red River cluster. It's got 3 machines on it. Kubernetes doesn't really want you to know too much about what's going on there. You can, let's see, there's a default pool and a better pool. You click edit. Okay, there's a few clicks to go, isn't there? Size, how do we edit that? Oh, you click edit there. Then do you click edit? Yeah, there we are. So if I wanted 10 machines, I'd press 10. And that would create a load of machines available to Kubernetes. You can also...
Okay, would you then configure it later on to have like the automatic startup?
That's this one here, so you can do it either way. If you just turn that on, when it's under load, it'll do a new one. That's probably what you're asking. Yeah, I should have said, yeah, there's a drop down, turn it to 1.
Yeah.
What colour do you want, Jake?
Can I have orange, please?
Oh,
Is it orange?
I don't know.
Just about.
Yeah. Dylan, we mix it up and then go back. We've only got 2, so...
Okay, what alternatives are there to Docker? And does Kubernetes only support Docker?
No, there's other backends. I don't know much about them. There's another thing that you can use instead of Docker. I can't remember its name, and Kubernetes can work with it. I think Docker behind the scenes uses some containerization engine that you can also use directly with a recent announcement. Don't know the details. I mean, a lot of the thing to bear in mind with this kind of new technology is what's the uptake like. You can find 1 million resources for Docker Kubernetes in pretty much any situation we're going to run into by the hipsters that have already got there first. But some other less popular one, you'd need to have a really good reason, I think. What colour do you want?
Your choice.
I was holding that one. Deal. Who wants the last bit? Ooh, I know Dan had a question as well.
Oh, go on, Dan.
In terms of sort of the building of all the components and things,
Yeah.
is there like a pre-existing repository of things
Yeah.
that you can source, or can you import things which may not be part of Docker and like that?
Interesting.
Problems because of the languages.
Yeah. So for the microphone, Dan asks, can you are there repositories or components or things you can pull in that you can use that are pre-built?
Yeah.
Stuff like that. So yeah, pretty much every level of this stack has the concept of a repository. So the Docker files and Docker images, there's Docker Hub, so you can find and publish to that. If you needed WordPress, it's a one-liner to spin up WordPress. As I say, if you need to pull in other components, you can you can pull that into your container. If in Kubernetes you needed to use something else, you'd probably use Helm. So in Helm, you say, I want this deployment and this service. Say for the little sample, it's the deployment and the service. You could then say, I also need this pulled in, and that is a load of stuff that someone else has done. That sits on a repository. I don't know if I'm answering it exactly, but pretty much it's all very composable, and there's repositories for all kinds of reusable things.
With the problem you said about the language aspect,
Yeah.
you had something which was in a completely different computer language.
Yeah.
If you were to want to build that in there, would you have to just completely write it from scratch?
Docker deals with any language pretty much will work. In fact, one of the benefits of Docker or Kubernetes for microservices is that you can mix and match. So the Docker file doesn't really care about any particular language. It just takes your program that runs on Linux. I haven't said that yet. There is some containerization with Windows Server, but this is all Linux. Everything I've talked about. If it runs, it's fine. When you're building microservices, which are apps made of lots of little containers and pods, you split it out into 10, 20, 100, 200. Amazon have thousands. Each service can be written in a different language. And because they're separate, it doesn't matter. So there's benefits there. Do you want the green one?
Cool.
Hey. Cool.
So that's when
Hello.
When you removed all of that stuff on the samples,
Yeah.
that looks a little dangerous.
Yes, very. Very scary. Yeah,
With great power comes great
absolutely.
So what, if you did that and went, oh shit.
Right now,
What's the recourse to that?
bad. It depends. So you can. There's not an easy way of backing up a cluster. You can export all of the resources in, and then with a deal of some degree of effort, recreate it. Part of the point is it doesn't matter if you delete all that stuff because it's just declarative, and you just recreate it. A persistent volume should persist because you just delete a persistent volume claim. Bit hazy on the details. You can have something called RBAC, role-based access control, so that you can say certain people can delete everything and other people can only create. Yeah, scary. You need to be careful. It is a tool, definitely. It's a power tool. It's like a nuclear power tool. And careful. Do you want to? Oh. Hi. And from now on, from here out, it's rubber bands. So Sam.
How easy is it to debug stuff? So with one is your
Yeah.
debugging?
Yeah. That's a great feature, by the way, if no one else has seen it. So Sam was asking, how do you debug? With Visual Studio, you can open that tab on the right. You can go down, find your app service plan, right-click debug, and you're stepping through. Lovely. With this, there's some things you can do. Pods, shares pod. This one. So here's a pod. I can click the logs button, so I'm going to build up to it and see what's been output on the console. I can get a shell, so I'm connected to it. Oh right, that's a one of them. Let's get something more long running. Like, where does the Dilbert microservice sit?
Red River.
It is Red River. Good. Oh, go to the wrong place. Let's try it here. So we have we have a load balanced. Doesn't seem to be changing the thing, does it? We have a load balanced, highly available Dilbert comic serving web service, and it has a pod. It has 3 pods, in fact. Come on. Cool. So I can look at the logs that it might have output. I can connect to it. It's Linux. So there you are. Demonstration of 2 Linux commands. Thank you. And further to that, debugging really means establishing a connection with a remote debugger. Now, I don't know, basically. With Docker running locally, you can connect with Visual Studio into a Docker container. With it running on Kubernetes, my thought would be you'd need to open some ports, enable the remote debugging monitor, blah, blah, blah. I don't know. I'm sure with JavaScript, so Node.js, the debugging setup there is quite straightforward. You need to expose how do you do that? Expose a service or something. Yeah, don't know. Could be a loss of that recently found massively beneficial cloud remote debugging thing. I guess the idea is it's an immutable deployment, so you deploy it locally. In theory, the whole point of this is that the environments can't differ that much. Your container is running in this little box, and it doesn't matter if it's sitting in a vast sea of other cloudy things or just on your machine, it should behave the same. But in practice, what if there's a firewall rule that's screwing it up? Or if it's out of disk space or something's going slow? Don't know. That's one to look into. Do you want an elastic band? Probably not. Yeah. Cool. Hello.
So for deployments, would a pod for us consist of the version of the backend and Node running the
There's
or would we deploy them separately so we can scale?
yeah, there's choices to make. So in fact, even yesterday we were talking about with Saffron 2, you can run like the API and the worker process on the same process or have them separately. So Luke's question was, would you deploy them separately as pods? The different components, front end, back end and stuff. You can choose. So you could have one pod which has both components. However, if you want to be able to update them separately, scale them separately, you can do them separately. And they probably have sort of different requirements, front end and back end. So the front end is going to be, for a single page up, served up like once, and then there'll be 100 requests to the back end. And it probably doesn't have much resource requirement. So you might say, well, 3 replicas of, or some small number, even 1 replica of the front end, but then we need this many APIs, this many worker processes, and actually they should be on a different class of physical machine that has more memory, because you can do that. You can say only to Kubernetes, you can say only place this pod in a venue that smells like beer, because the drummer only performs best in that environment, whereas someone else put them in a machine that's a fine, trendy wine bar, because that's where a violinist performs better. I don't know. Pushing it a bit. Yeah, you get to decide. I don't know. My thought would be back-end stuff together and front-end stuff together separately to minimise the chance of when you're updating everything, the front-end not serving stuff up, but it should handle that for you. There's not an answer. There's not a definitive answer. Yeah. Any more for any more? I like doing it just before lunch because everyone's like, as opposed to just after lunch. Everyone's like, okay, we done?
Mm-hmm.
Cool. All right, thanks.
Thank you.
Got a clap. Was that really only 36 minutes?